How do we geometrically decompose vectors into parallel and perpendicular components? Well, first we have to figure out what the positive directions are going to be and construct a right triangle of whatever vector we're decomposing into parallel and perpendicular components. Then we'll use sine and cosine to calculate the magnitudes of the components and then make sure that you assign your positive and negative signs correctly. So, if we have this inclined plane, 20-degree angle there, and the weight of an object is 8 newtons, typically what we'll think about, what's more useful to think about, is for our coordinate system to be, positive x is in that direction, and then positive y is in that direction. So those are our positive x and positive y. So because that's the case, this is not parallel or perpendicular to either of these, and we want to split it into parallel and perpendicular components. So let's draw a perpendicular component and a parallel component, and that will make a right triangle. The angle here is 20 degrees. Based on this is 20 degrees, so then this is 70 degrees, and then this is another 20 inside. If that triangle is too small, it might make sense for you to redraw it bigger so that you can see. This was 8, this was 20 degrees, and now we can use sine and cosine in order to find the parallel and perpendicular components. So this is going to be 8 times, well, it's opposite, so it's sine of 20 degrees. And our adjacent side, our perpendicular side, will be 8 cosine of 20 degrees. So this is how we compose into parallel and perpendicular components. If we're looking for exactly what those are, frequently the notation I use is that the parallel component, this is the parallel component, and it's facing in a negative direction. That was our positive x, so this is a negative value. And then we'll say, what's 8 times the sine of 20 degrees? So it's approximately negative 2.74 newtons. As for the perpendicular component of the weight, we will use cosine. This is also in a negative direction because that would be the positive y, so this is negative y. And now we have 8 times cosine of 20 degrees, which gives us negative 7.52 newtons. Here we have another case of weight, where the weight is 20 newtons. Let's assign this to be the positive x direction, and this is going to be the positive y direction. So parallel, perpendicular. If we decompose this into parallel and perpendicular vectors, there's the perpendicular part, there's the parallel part. So let's see. This 60 degrees, this is parallel, and this is, let's see, so that 60 degrees, should this be 60 degrees or is that going to be 60 degrees? I believe that this is going to be 60 degrees. Let me double check. If this is 60, then this will be 30. This will be 30. So yeah, that'll be 60. This will be 30. Okay, so now we have our right triangle. We can say that this is going to be 20, and because it's the adjacent side, it's 20 times the cosine of 60 degrees. This is going to be 20 times the sine of 60 degrees. So the parallel component, is this 20 sine of 60 degrees. Sine of 60 degrees is square root of 3 over 2, and then times 20 gives us approximately, I keep writing equal signs, 17.32. And that is a positive direction because it's down the ramp. Downward the ramp was what we assigned to be positive x. The perpendicular component of the force due to gravity is, let's see, it's in a negative direction. And it's based off of 20 cosine 60. So cosine of 60 is a half times 20 gives us negative 10 newtons. So this is how we geometrically decompose a vector into its parallel and perpendicular components.